Good afternoon. Welcome back to Algebraic Connections. Today, our third standard for the quarter is matrices. Matrices is the plural form for a matrix. We're going to talk about adding, subtracting, and multiplying by a constant, which we also call scalar multiplication of matrices. All right, a matrix. Let's go through some terms. Matrix, which is the singular form of matrices, is a rectangular array of numbers often represented by a capital letter. An element of a matrix is in each individual entry in the matrix, often represented by a lowercase with subscripts indicating the rows and columns. The dimensions of a matrix is the number of rows and columns in the matrix. A matrix with 2 rows and 3 columns is known to be a 2 by 3 matrix. Let's look closer at that. We've already said a matrix is shown by a capital letter, such as A or B. In this case, we have A, we have B, and these two. Each entry or element is shown by a lowercase letter. Here we have our lowercase letter, letter A, 3 times across the first row, 3 times across the second row, with a subscript. These subscripts represent the rows and columns. Notice, everything here has 1 as the first number because it's of the first row. Everything here has 2 as the first number because it is of the second row, and then the column goes as 1, 2, 3. So in our example matrix, we have a 2 by 3 matrix, matrix B, with 2 rows and 3 columns. -1 is the entry for row 1, column 1. 4 is the entry for row 1, column 2. -3 is the entry for row 1, column 3. And the same thing for row 2 below it. If 2 matrices have the same dimensions, meaning the same number of rows and columns, then the elements in the same positions are called corresponding elements. Notice here, we have corresponding elements here. Row 1, column 1, in that spot. Row 1, column 2, these are corresponding elements. Row 2, column 1, and row 2, column 2. The corresponding elements are highlighted as with the same color. If you have matrices with the same dimensions, you can do basic arithmetic, adding and subtracting with these matrices. So if we look at 2 by 2 matrix, 2, -3, -4, 2, and -1, -5, 3, -2, you can add by adding the corresponding elements. 2 plus -1. 2 plus -1 is 1. -3 plus -5. -3 plus -5 is -8. -4 plus 3 is -1, and 2 plus -2 is 0. So this is our resulting matrix of adding these 2 matrices that have the same rows and the same columns, the same dimensions. Same thing with subtraction. 2 minus -1. 2 minus -1 is 3. -3 minus -5. That is 2. -4 minus 3 is -7. 2 minus negative 2, it is 4. Some have been taught pre-algebra, algebra 1, when you have subtraction, you could change subtraction to addition by a method called keep, change, change. Subtraction is the same as adding the inverse. So if I change this to addition, that means I would just go change the signs of all things in the matrix. So you'll understand where I get this resulting matrix from. All right, give you about a minute or two to practice on your own. So notice that in number 1, we have 3 by 2 matrices. This is a 3 by 2 matrix, 3 rows, 2 columns. 3 by 2 plus a 3 by 2 will result in the 3 by 2. 2 plus negative 1 is 1. 1 plus 9 is 10. 5 plus 11 16, 6 plus 6, 12, 7 plus 1 is 8, and 3 plus 7 is 10. Hopefully you got the same thing at home. All right, to subtract, this is a 4 by 2, 4 rows, 2 columns. So 7 minus 8, you must add or subtract corresponding elements. 7 minus 8 gives us negative 1. 2 minus 4, negative 2. 6 minus negative 6 is 12. 6 minus 7, negative 1. 5 minus negative 3 is 8. 8 minus 2, 6. And 3 minus 6, negative 3, negative 1 minus 1, negative 2. Your resultant matrix will also be a 4 by 2. So let's review solving equations. One-step equation, solving equations. 7 plus a number equals 10. So inverse operation, to get rid of the 7, we would subtract 7 from both sides, and b will equal 3. 7 plus 3 equals 10 if we were to check that. The inverse of a negative 5, to get rid of a negative, you would need to add. So adding 5 to both sides, and b will equal 9. The inverse for this one here, subtract 5 because it's positive. 7 minus 5 is 2. The inverse of 4 is to subtract 4. Negative 9 minus 4 is negative 13. So this is just a review of solving equations. In just a second, you'll see why we reviewed this. So if you're given a matrix equation, in this case, it says find B if this matrix plus B, meaning B will be a matrix, equals this matrix. So you would take the same thing using corresponding elements. 7 plus b equals 10. This is exactly what we did here. Five plus b equals 7. That was done there. Negative 5 plus b equals 4. 4 plus b equals negative 9. So this, mathematically, we would subtract this matrix from this matrix just to show in matrix form on both sides. And matrix B equals, same information we got here. 3, 9, 2, negative 13. To check it, 7 plus 3 equals 10. Negative 5 plus 9 does equal 4. 5 plus 2 does equal 7. And 4 plus negative 13 is negative 9. Let's look at another equation. So they want us to find t. Find t if t, meaning t is a matrix, minus this matrix equals the other matrix. Well, what's the dimensions of these matrices? These both have 1 row and 3 columns. So your resulting matrix will also be a 1 by 3. The dimension is 1 by 3. So if we was to bring this over, it would be t minus 7 equals 5. T minus negative 2 equals 2. T minus 3 equals 9. Add 7 to both sides, and t equals 12 here. That's change that. So that's like plus 2. So you'll subtract 2 from both sides. So t equals 0. Add 3 to both sides. T equals 12. So keep in mind the dimensions have to be 1 by 3, 1 row by 3 columns. So we have to put it in a matrix that has 1 row and 3 columns. 1 row, 1, 2, 3 columns. We also have scalar multiplication. You have a scalar that you will multiply a matrix by. 7 is my scalar. We will multiply each entry into this matrix by 7. 7 times 4, 7 times 8, 56. 7 times negative 3, negative 21. And 7 times 2, 14. Okay, so in this example, They want us to find 3A, 3A, meaning we would multiply everything in matrix A by 3. So 3A equals, multiplying all of these by 3, -9, -6, 15, 3, 12, -3. So that's 3A. 2B, multiply everything in matrix B by 2. So that is 8, going down the column, 0, -4, -3 times 2, -6, -4, 8. Multiply everything by 2. Let's look at it again. If A equals -3, 1, -2, 4, 5, -1, and B equals 4, -3, 0, -2, -2, 4, then what is 3A minus 2B? Meaning everything in matrix A we multiply by 3. Everything in matrix B we multiply by 2. Once we multiply, then we can subtract. We're combining scalar multiplication and subtraction. So now we have -9 minus 8, which is -17. 3 minus -6, which is 9. -6 minus 0 is just -6. 12 minus -4, 16. 15 minus -4 is also 16. And this should be a -3. That's a glitch. -3 minus 8, -11. Multiply everything by 3 in matrix A. Multiply everything by 2 in matrix B. And then we subtract. And this is our result. -17, 9, -6, 16, 16, -11. So let's take a look at some more problems. Adding, subtracting, multiplying, scalar multiplication. All right. Use addition, subtraction, scalar multiplication to find the matrices. If the operation cannot be done, write CBD. So let's look at one on each slide for the sake of time. Let's look at number 2. A plus B plus C. Are they all the same dimension? This is a 2 by 3. This is a 2 by 3. This is also a 2 by 3. Because they all have corresponding elements, meaning they're in the same dimension, they can be added. So 2 plus 6 plus 0 is 8. -1 plus 10, that's 9, plus -2, that's 7. 5 plus -5 is 0, plus 3 is 3. 3 plus 5 is 8. Plus -5 is 3. 0 plus 1, -1 is -1, plus 11 is 10. 14 plus 2 is 16. Plus 4 is 20. So this is our resulting matrix when we add matrix A plus B plus C. Let's look at number 3 this time. They want us to subtract. D minus E. Once again, you must have the same dimensions in order to add and subtract. So this is 3 by 2. E is also 3 by 2. Negative 1 minus 1. Negative 2. However, I did E minus D instead of D minus E. So that should be 1 minus negative 1. And that's 2. Negative 4 minus negative 1. That's negative 3. 7 minus 6 is 1. 2 minus 7 is negative 5. 6 minus negative 2 is 8. Negative 8 minus 10 is negative 18. So let's look at number 6. 3 times H. Well, H is here. So we're going to multiply everything in this matrix by 3. That's negative 12, 12, 3. Negative 4 times 3, negative 12. 4 times 3 is 12. And 1 times 3 is 3. All right, so before we go, these are our 8 matrices that were given. Use these matrices to write an expression that would create matrix X. Add, subtract, scalar multiplication, however you like to do it. These 8 matrices, you can write an expression to create this matrix. Once you figure it out, screenshot, take a picture, however you want to do it. You can send it in to me. You can find me Twitter at Coach DJ2, Instagram at d.july2. These are your 8 matrices. Use any combination to write an expression that would create this matrix. I have 2 Food Cyclist gift cards at this point. Whoever get it to me first, via Twitter or Instagram, I'll get those gift cards to you. Let you look at it one last second before we move on. Hope you all have a good evening.